The inverse of a function is found by reversing the order of the coordinates in each ordered pair. So for instance, suppose I have the function f that's defined by these three ordered pairs right here, 1, 5, 2, 7, 3, 9. We find the inverse of f by reversing the order of the coordinates in each ordered pair. So 1, 5, when it's reversed, becomes 5, 1, 2, 7 becomes 7, 2, and 3, 9 becomes 9, 3. Now this set of ordered pairs right here, which is different than this set right here, is the inverse of my original set. So if f is this set of ordered pairs, the inverse of function f is this set of ordered pairs right here. Now, we're not usually given a set of ordered pairs to define a function. Usually we're given a rule that tells us how to get the ordered pairs. Now, if f is given by, let's say, the equation y is equal to 3x minus 1, we can find the equation of the inverse by simply interchanging the variables x and y in the equation, and then we'll have the equation of the inverse of f. So x equal 3y minus 1 will give me ordered pairs in which the coordinates have been reversed from the ordered pairs in this original function right here. So all functions have inverses, some of which are functions and some of which aren't. We'll get into that in a minute. But the inverse of a function is the set of ordered pairs with the coordinates reversed. Now, if we're given the equation of a function, we can find the equation of the inverse by reversing, by exchanging the variables x and y in the equation. Let's look at an example. For example number 1, I have f of x is equal to 3x minus 1, and I want to find the inverse. Well, I'm going to go back to my notation for y, and that is I'm going to write y equals 3x minus 1. Now, to find the inverse, okay, the inverse is x equal 3y minus 1. So this is my original equation right here. Now this is the equation of the inverse. And I find the equation of the inverse by simply exchanging x and y in my original equation. Next, let's solve this for y. So I'll add 1 to both sides and exchange the sides, so I get 3y is equal to x plus 1. Add 1 to both sides, and then I'll write the x plus 1 over on this side and the 3y on this side. Now I'm going to divide both sides by 3. So I end up with y is equal to x plus 1 divided by 3. So this is the equation of the inverse of this function right here. So if I say y is equal to 3x minus 1, its inverse is y equal x plus 1 over 3. Notice that the function itself multiplies x by 3 and then subtracts 1. The inverse adds 1 and then divides by 3. The inverse operations in the reverse order. Now let's take a look at some ordered pairs, and also I want to graph these two functions on the coordinate system here. So let's look at some ordered pairs. First I want to write down, I'll copy the functions down again for you. So first of all, here's my function, my original function, y equals 3x minus 1. Now let's find some ordered pairs. Let's let x be equal to 0. When x is 0, y is negative 1. Let's let x be equal to 1, and then I have 3 times 1 is 3, minus 1 is 2. And let's try one more. How about a negative value of x? What about negative? Let's put in negative 2. 3 times negative 2 is negative 6, minus 1 is negative 7. Now let's look at the inverse of f. I'm sorry, the inverse function, or the inverse relation. I'm not sure it's a function yet, although it is linear. Now let's substitute into this. Let's substitute in x is equal to negative 1. When x is equal to negative 1, I have negative 1 plus 1 is 0, divided by 3 is still 0. Notice that that's the same as this ordered pair with the coordinates reversed. Let's see what corresponds to this ordered pair by substituting in x equal 2 into my inverse. 2 plus 1 is 3, divided by 3 is 1. And down here, let me substitute in negative 7. Negative 7 plus 1 is negative 6. Negative 6 divided by 3, negative 2. So you can see that, in fact, if I have my original equation right here, I exchange x and y and then solve for y, I get the equation of the inverse of my original function right here. Now, this original function had these three ordered pairs among its solutions. Now, I take the equation of my inverse and I find three ordered pairs, and I find that they're the same ordered pairs I had up here, just with the coordinates reversed. So, in fact, reversing or exchanging x and y in the equation does reverse the coordinates in all the ordered pairs, giving you the equation of the inverse. Let's look at the graphs of these two. First of all, let's graph this inverse right here, y equal x plus 1 over 3. I'll use these 2 points. X is equal to negative 1, y is 0. and x is equal to 2, y is equal to 1. So there's that point. Now let me draw a line between those 2 points and see what we get here. Let's see, that's about like that. Okay, so that red right there, that's the graph of the inverse. Now let's graph the original function itself. X is 0, y is negative 1. That's right here. And x is 1, y is 2. So I'll go forward 1 and then up 2. So x is 1, y is 2. Let's sketch the graph of that by drawing a line between those points. Okay, so there's the graph of my original function right there. Y is equal to 3x minus 1. This is the graph of y equals x plus 1 over 3. And what you will notice is that if you were to draw in the line y equal x, which would look just like that, that my 2 graphs are symmetrical about this line y equal x. So if I draw in the line y equal x, you see that the 2 graphs, if I reflect one of them about the line y equal x, I'll get the other one. So this graph and this graph have symmetry about the line y equal x. Okay, so that's one of the relationships that we have between the graph of a function and the graph of its inverse.